Hey guys, go ahead and get out your notice sheet for direct variation.
Alright, so the definition of direct variation is where y varies directly as x, and that'll kind of start to make a little bit more sense than a little bit, so let's just jump into the formula. So formula is y equals kx, and k is your constant of variation, and then x and y are considered points of your equation that would make it true. If you kind of notice and look at this formula, it looks very similar to y equals mx plus b, but we're changing m to k because it's going to be a little different the way you find k instead of m. And then there is no b, so if there is absolutely no b, that means that b would have been 0, which just means all of these go through the origin. So again, your formula for direct variation is y equals kx, and when you're doing direct variation, you're going to need to find the constant of variation, which is that k. And so if you think of k or this equation as a literal, and you wanted to solve this for k, then you are going to just divide by x. So the way you're going to find k in all of the problems that we're going to work out is just by doing y divided by x. And again, the way I did that is by taking that normal formula, y equals kx, dividing by x so you can get k by itself. So when we find our constant of variation, you literally just have to take your y value and divide by x in order to get your constant of variation. So your steps to write a direct variation equation would be to find k, which is your constant of variation. Again, to do that, we're just going to divide y by x, since that's how you would find k from that original formula. And then if we're going to write the direct variation equation, we need to write it back into that original equation, which is y equals kx. But now we know k, so we're going to substitute k back into your formula. And then you're done. So we've got 3 examples that we're going to take a look at of writing your direct variation equation from these tables. And something to kind of take note of for direct variation, which should happen for all problems. If there's a pattern going on in your x's and your y's, and you notice that your x values are increasing from 6 to 7 to 8, then the y values should also be increasing. They don't have to increase by the same amount, but they are increasing. What you should never see is one side increase while the other decreases. So we're going to go ahead and do our steps, which is find k. So again, we said k is y divided by x, so you can pick any of these, and we can do 12 divided by 6. If we wanted, we can do 14 divided by 7. We can also do 16 divided by 8, and what you should always notice is that all of these give you the same value, which is 2. So our direct variation equation, we're going to plug in k, which is 2, and we're going to write this as just y equals 2x. So it's kind of finding the slope without having to do anything with a y-intercept, but finding the slope for these is a little easier. You don't have to subtract or do anything crazy. You literally just divide y by x. So your second table, you look at the x's and the y's, and this time the x's are decreasing and then so are the y's. So again, that should always be consistent. They should kind of follow each other, so never opposite. They both either increase or decrease. So again, we're going to find k, so we're going to do y over x. Just like slope is change of y over change of x, this is just the division of y over x. And if I take any of these and divide each of them separate, k should be for all 3 of these 3. 30 divided by 10, 15 divided by 5, 9 divided by 3. So then we substitute k back in for our original equation, and we just get y equals 3x. And then your third example, x's are decreasing, and then so are the y values. So when we go to find k, again, it's that y value divided by the x value, and I can check any of these, and all 3 of them, if you do the division, negative 1 over negative 4 can be simplified to 1/4. Negative 4 over negative 16 is also 1/4, and then negative 10 over negative 40 is also 1/4. So this time k is 1/4, and our equation should be y equals 1/4 x. All right, go ahead and pause and try this one on your own, and all you have to do for this one is find k. Alright, so what you should have gotten for this one is k is -2, and if you divide any of these y's by x's in the table, you're going to get that -2. Hopefully this is pretty easy to you so far. Direct variation actually is pretty easy. We're just going to add a little bit more things to it, and still is a pretty basic concept though. Alright, so the next thing we're going to do is actually determine if direct variation exists, because some of the questions you'll see will say, is this direct variation? And it's kind of a yes or no. So what you're going to need to do is to check that the constant of variation, or k, is the same value for the entire set of ordered pairs. Now, I was kind of already doing that in the examples we've done before, but technically in those top examples, we could have just checked one of those since we knew they were all direct variation, but I was doing it anyway to prepare you for this. So what you need to do is check the entire table that y over x is consistent, and if it is, then yes, there's direct variation, and then you would write your equation. So we're going to practice that with the next few problems. All right, so what we're going to do first is determine if k is constant and consistent throughout this entire table. So we need to see, is 6/4 equal to 12/8 and equal to 18/12 and also equal to 27/18. So these are all fractions. We're going to want to reduce them to the lowest form. So I know 6/4, 2 goes into that, so we got 3/2. 12/18 can be reduced by 4, which would give you 3/2. 18 over 12 can be reduced by 6, which gives us 3/2, and 27 over 18 can be reduced by 9, which gives us 3/2. So because all of these are the same, then k is constant, so yes, this is direct variation, and then the equation would just be y equals 3/2 x. So we kind of have already done this, but you really should do it for all problems anyway. Determine if direct variation is there. If so, then write the equation. If not, you just say no. Okay, so second example, we're testing if 25 over 10, which is y divided by x, is the same as 15 over 6 and 10 over 4, and then 5 over 2. So I know I can reduce by 5 here to get 5/2. 15 over 6 can be reduced by 3 to give you 5/2. 10 over 4 is reduced by 2 to give you 5/2, and then obviously 5/2 is 5/2. So this one is another yes, direct variation exists, and then we would write our equation using what your constant of variation was, which was 5/2. Okay, and then last one you could try on your own and then press play when you want to check it. Okay, so if you wrote these out, y over x, it's probably pretty obvious right away that this one's no. And the reason why you want to check all of these is because sometimes maybe 3 of the 4 would be all the same, but then there's that kind of one misfit. Here we can clearly see these don't work, so you don't have to write an equation. Your answer is just no, it does not exist for this. Okay, go ahead and pause the video and then pick which one of these has direct variation. So there's only one of these that's direct variation, which means which one has k consistent for all ordered pairs, and pick that one only. Okay, so this time I wrote my answers to the side of the table, but the answer should have been A. I cannot circle A though. And if you do the y divided by x for each of them, I wrote out what you get for each table. So they're all -2 for A, which means yes, there's direct variation. B kind of mixes up a little bit. C has both 1/2 and 2, which is no good. And then D has positives and negatives, which is no good. They have to be exactly the same in order for there to be direct variation. Go ahead and pause and then try this one and pick the equation for this table in direct variation. Okay, and your answer for this as a direct variation equation would be option 3, that k, found by y over x, would be 5 over 10, or 1 over 2, or 6 over 12, or 10 over 20, and in that case, then k would be 1/2. Okay, a lot of the problems with direct variation, you're going to have information and then use that to find a missing value. So what you would do in 3 steps would be, again, find k, write your direct variation equation, which is what we've already been doing, and then use that equation to solve for the missing value in the next part of the problem. So let's take a look at how those will work. Okay, so for some people you might want to actually make a table, if a table is easier for you to follow, by using the information. So here it says, given that y varies directly with x, and that just means that there is direct variation, and that y is 28 when x is 7, we're going to figure out what x is when y would be 52. So again, we're going to start by finding k, and we can only use that first group and do y over x, which is 28 over 7, so k is 4. Now I'm going to write my direct variation equation, plugging in k, and then I'm going to go ahead and use this to predict. So in the next situation, I know that y was 52, so I'm basically saying 4 times what gives me 52, and then you can divide by 4 and work a little backwards to get your answer, and then we should get x is 13. And that should be it. Okay, for the next one, it says y varies again with x, and y is 3 when x is 9. What would y be when x is 40.5? So again, we're going to find k by doing y over x, which would be 1/3. We're going to write our equation, which is 1/3 x, and then we're going to go ahead and plug in so we can solve. So this time we're actually solving for y when we know x, so we're going to plug in 40.5 and multiply that by 1/3. And we end up getting y equals 13.5 for this direct variation. Go ahead and try this third one on your own and then press play when you're ready to check it. Alright, so k would just be -6/5, can't really reduce it, and you want to leave improper. So then we're going to plug in x and multiply that by -6/5, and we should get positive 48/5. And as a decimal, that'd be 9.6, but probably better just leave your fraction. Alright, and then the last main thing we're going to talk about is word problems with direct variation. So the key to this would be to identify the x and the y in words, which one's the x, which one's the y. And then if you prefer, make a table. I think the table is definitely very helpful so you don't mix up your information. Once you have that table and you understand which is x and y, you're going to find k again, which is what we've been doing. Write your equation, which again is what we've been doing, and then use your equation to find the unknown from the word problem. So let's take a look at how this would work. So example 10 says that a car uses 8 gallons of gasoline to travel 290 miles. How much gasoline will the car use to travel 400 miles? So first of all, you want to think of the x and y again as independent and dependent variables. So you're saying, you know, the independent variable is the one that's affecting the other. So is it the amount of gallons that you have affecting the miles you can go, or, you know, vice versa? And I know the table here is already labeled for you, but that's not always going to happen. So you would have to understand that it is the amount of gas that your, you know, car can hold, or the gallons of gas that your car can hold, that's going to affect how many miles you can travel. So for our table, we know that 8 gallons will give us 290 miles. We want to know how many gallons are going to give us 400. And so we would again find k. So we're going to do 290 over 8. And that's basically going to give you how many miles per gallon your car would be able to travel by doing it this way. And we end up getting k is 36.25. And I'm going to leave decimal here, that's fine. So our equation is y equals 36.25x. And then I'm saying how many gallons, which is x, to go 400 miles. So I'm going to plug in my 400 for y and solve for x by dividing. And we should end up getting about 11. So it's a decimal. It's kind of a weird decimal, but we're going to go ahead and just round. We're going to get somewhere around 11.03. I'm just going to keep it as 0.03. So that's it for the word problem. Another thing that you could technically do here, this is actually a proportion as well, but I would rather you guys do them as, you know, direct variation equations to just get more practice with that. But you could have just made these fractions with an equal sign and cross multiplied and divided to get the same answer as well. But again, I would prefer you to just use the direct variation equation. Right, and then your last one, number 11, says that Julio's wages vary directly as the number of hours that he works. If his wages for 5 hours are $29.75, how much will they be for 30 hours? So something with word problems and the way they're worded like this, and again, I know I have the table here, but if it says his wages vary directly with the number of hours, they're always going to give you the y and tell you that the y depends, varies directly is kind of like saying depends on the x, which tells you that the second thing they give you is always the x, or that independent variable. So his wages for 5 hours was $29.75 if we fill in our table, and then we want to know how much would he make for 30 hours. So again, we're going to find k by dividing $29.75 by 5, and that's going to basically give you his hourly rate, and that's going to be $5.95. We're going to write our equation, so y equals 595x, and then we're going to solve for y this time, his total wages after 30 hours. So multiply his hourly rate times 30, and we end up getting $178.50. Because it's money, you're going to want to keep 2 decimals. But that's it. So just paying attention to which one's y and which one's x. And again, I drew the tables on the notes. You're not going to have those, so you're going to have to understand which one's which. And the last thing, which is really no math for this, is just kind of comparing this direct variation and talking about its graph and comparing it to slope-intercept form. So with slope-intercept form, we know we had mx plus b, and then we also know that, you know, m was your slope, and then b was your y-intercept, and now we've got this y equals kx. So I kind of already mentioned earlier that it's similar to slope-intercept form, except there is no b. And instead of m, we call it k because you can find it a little differently. So m and k are both representing a slope, though. It's just a different way of finding them. That's why they're different variables. And then b is still a y-intercept, but if there is none in direct variation, that's going to prove that every direct variation graph is going to go through, hopefully you figured it out, the origin at 0, 0. So hopefully you figured that out. Go ahead and write it in. And we're going to take a look at a couple graphs so that you can just kind of identify if it's direct variation or not. So direct variation has to be a straight line, has to go through the origin. First example here, direct variation, nope. Second example, looks like it wanted to be, but it is not going through the origin. Third example, a straight line, not through the origin. Fourth one goes through the origin, but it's not a straight line. So actually all of these are no's. And lastly, this first top left one is a horizontal line, but does not go through the origin, so nope. Finally, we get a yes going through the origin and straight. This third one kind of looks like it wanted to be, but again, it's not directly through the origin. And then this last one, again, is a no. So straight line through the origin, easiest way to identify direct variation. And that is officially the end of these. We will practice a little bit more with this in class when I see you guys again.